Hey everyone, it's Mr. McMahon again. Today we're going to talk about percent composition, molecular and empirical formulas, and just do a little review at the end. So first, what is percent composition? If you remember back to class, we talked about the individual divided by the whole. If I wanted to find the percent of guys in my class, I would take the whole, and then I would divide the guys by the total. Same if I wanted to do it for the girls or teachers or whatever. So in order to do it in chemistry, we're going to use the molar mass. And from there, we can determine the percent composition based on the mass. So there are three main steps. First, let's determine that atomic mass for each element in the compound. So I look on the periodic table, I find what number I have. Then I add them all up and I get the overall molar mass. And after that, I'm going to divide the individual element by the total. So let's take a look at a sample problem. So if I were to calculate the percent composition of barium sulfate, I would take the molar mass of 1 barium, 1 sulfur, and 4 oxygen, which I did here, add them all up, and you'd get 233.4. Now to figure out the percent composition, I'm going to take this total number of mass for the Ba, the S, and the O and divide it by my total. Right there. So 58.8%, 13.7, and 27.3. Now, it should add up to 100. This is pretty close. It's like 99 point something. I get that. 99.8, I think. So, or 98.8. So, but it should be 100. It's not always going to be exact. But for the most part, if you do it, you are going to get very, very close. And that's the way that you can check yourself to see if you've done it right. So this one, like I said, was 99.8%. So again, another one, let's check C6H12O6. I've got 6 oxygens, 12 O's, and 6 carbons. I do the math, and I get 53.3%, 6.7, and 40. But now notice, a lot of you would think that this is going to have the most percentage-wise, but in actuality, since we're doing it by mass, it's reasonable to make that assumption, but not with the mass. 96, 12, and 72, so it should be the most, then that one, then that one. Now try to do this problem. What is the percent of oxygen in HNO2? What is the percent of oxygen in HNO2? Now maybe pause this presentation so you can try it. Okay, now that you're back, let's hope that you got the right answer. It is C, 68.06% oxygen in HNO2. Now, empirical and molecular formulas, the other new thing. So an empirical formula is just a formula in its smallest number ratio, whereas the molecular formula is a formula that shows the actual number of atoms in a molecule. Now, they could be the same thing, okay? So they don't always have to be two different ones. They might actually be the same. So here's an example. Glucose, C6H12O6, molecular, empirical, CH2O. Now let's try these on your own. Determine the empirical formula for these. H2O2, C3H8, C4H12. Maybe take about 30 seconds, pause this, and come back. Welcome back, everybody. HO, C3H8. Oh, look at that. That was tricky. I can't break it down anymore. And CH3. Hopefully you got those right. Now, when we're doing these, first thing you need to do is to change your percentages into a decimal form. You can divide by 100, move the decimal left, it doesn't matter. Then you calculate the mass of each element by multiplying the percent by the molar mass. Calculate the moles of each element by converting the mass of the elements to moles using dimensional analysis or stoichiometry. So in this one, I put them in a kind of a line thing because some of you, I've noticed, have started to do this. And we'll go through there. So first, the molecular formula contains the element symbol with the number of moles written as a subscript. Reduce that subscripts to determine the empirical. So here's an example given. Notice the molecular and the empirical are the same. I have 59.37% lead right here, and I have 40.63% chlorine right here. The molar mass of Pb in the Cl was 349.0 grams per mole, so I gave that to you. Which means that I have 207.2 grams times 1 mole over 207.2 gives me 1 mole. And 141.8 times 1 mole over 35.45, which is 4. 1 PB, 4 CLs. Now notice, This here is just the same as times line, but some of you like it this way, so I wanted to show you a slightly different way to do it. The second example here, 58.8% carbon, 9.8% hydrogen, and 31.4% oxygen. Notice this 9.8 is 0.098 when I multiply through. I do my divisions, 5, 10, and 2. If I were to divide them all by 2, I'd get 1. I would get 5, and I would get 2.5, which means that is not a whole number. So this is the same again, molecular and empirical. So just some stuff to review. This is older stuff. Some of them are 2 steps. Some are 1 steps. Some are just straight molar mass. But I wanted you to try to do this. So pause this, do all of these, and when you're done with that, come on back and you'll get the answer. Well, how'd you do? Here are your answers to the first 5. Notice grams per mole. Grams, because look, I was looking for mass. Moles, because I was looking for moles. Grams, because I was looking for mass. And molecules, because I was looking for that. Notice, no moles, 2-step problem. No moles, 2-step problem. Oh, moles, 1 step. Oh, moles, 1 step. Here, just the molar mass. And a little more review. Barium hydroxide, same sort of thing. Pause it, go through these 5, and come back. Well, I hope you got them all right. Let's take a quick look here. What is this? Oh, just molar mass. This here is a 1 step because of the word moles. 1 step because of the word moles. No moles in these 2, so they're both 2-step problems. And here are the answers so that you have them. What about a quick multiple choice review? Calculate the mass of 0.200 moles of H2S. Very good. B, 6.82. Well, for homework, come to class tomorrow with any questions on this stuff. Quiz will cover 2-step problems and 1% composition and 1 empirical formula problem. I'm sorry I'm not here today. I hope this did help. And for those of you that are watching it tonight, you're going to get the same video in class tomorrow. Have a great evening or a great day, and I will see you all on Wednesday for our quiz. Thanks a lot and have a great day.